So here I've written down the first several questions that are on the 4.5 study guide. So it starts out with a set of equations that give us the population of these countries T years after 2013. So as we work with these population models, we need to remember that T is measures the years since 2013. Okay, so now working through these questions. Hopefully you have the PDF handy so you don't have to rely on all of my writing here. But first question, what is the population of Wessex in 2013? Or what was the population, I guess, is what I should have said here. But so if T is the years, T represents years since 2013, then in 2013, T is 0. It's been 0 years since 2013. So we would go to the population model for Wessex, that second equation, and substitute 0 for T. So this is e to the negative 0.015 times 0. And so when we work this out, you'll have 12.7 times e to the 0, when you multiply 0 times that value of k. And any non-zero base raised to the 0 power is 1. So this is 12.7 times 1, 12.7 million. Yikes. That's our answer to this question 1. I'll record it over here because I'm going to erase that in just a second. One thing that we might note here. So we ended up getting just this coefficient value, in this case 12.7, which if you look at the general model that I've written in the study guide for this section, the general model for population growth is A equals A naught or A0, which represents the initial population. I'm going to make that note here. So this is the initial population. Times e to the kt, where k reflects the either growth or decay rate of that population. But this coefficient in front is the initial population. So we could have answered that first question just by looking at the function. And we could do the same kind of thing with this second question. What's the population of Umbria in 2013? So again, we're talking about when these models start. They're the starting point. And so we're looking at we're asked for the starting population. So we could just look to the equation and identify 7.3. Notice, I mean, if we wanted to work it out the same way we did that last one, we would say, okay, 2013. So that's 0 years since 2013. If you plug that in, you're going to have e to the 0, which is 1, times 7.3. So the answer to question 2 here is 7.3 million. And the lesson learned there is if you want the initial population, all you have to do is look at the coefficient in front. Okay, but the next two questions, so the population of Wessex in 2025 and Umbria in 2030, now we're not talking about initial population anymore. So in this case, the first task would be to identify the value of t that we need. I'm going to erase to give myself some room here. So 2025, that'll be 12 years since 2013. If we add 12, we get 2025. So we should take the population model for Wessex. A equals 12.7 times e to the negative 0.15 times t. So now we're going to plug in 12 for t. So this problem becomes more of a calculator question, because now the key is just inputting this into your calculator correctly. So one word of caution when you're doing that, you're going to need exponents around, or exponents. You're going to need parentheses around the exponent, is what I meant. If you don't insert parentheses, your calculator is going to follow order of operations, so it's going to take e to this negative 0.015 power first, and then multiply later, because that's where it falls in the hierarchy of the operations. But so if what we mean is for the 12 to also be in the exponent, then you need to put parentheses around it. And so if you do that, we get about 11.4 million when you type that in. Now the fact that it's a little bit less than the starting amount of 12.7 should not be a surprise, because we have a negative value of k. So that tells us that the population is in decline. So we're expecting a lower value. So this seems like a good answer. 11.4 million for question 3. Now for question 4 here, it's the same idea. Umbria, so we're going to use a different population model. And 2030, so we have a different t. But same basic idea. So population of Umbria in 2030, t is years since 2013, so that's 17 years later. Plug that into your Umbria function, 7.3. Now I'll write this more the way it's going to look when you input it into your calculator. So 7.3 times e to the, so it'll probably look something like that once you put it into your calculator. Now I've noticed a lot of these TI calculators, when you do you'll hit second and then ln to access this exponential function. A lot of them will automatically open a parentheses, which is good in this case. Sometimes it kind of sets a trap, but in this case it's helpful. So this should be e to the 0.015 times t, which in this case is 17. So this is basically what that should look like when you punch it into the calculator. And the value you should get is about 8.7. Oh shoot, yeah, I just realized I was working these problems with old values. So I really don't want to redo the whole video, but this 2025 is going to be incorrect. Let's see, Wessex. Well, here, let me answer this one first. So for Umbria in 2030, we want 7.3 times, I was using values I had in my calculator from previous edition of this video, but I've since changed the values of t. Here, let's stick with this one. We need to correct the answer to question 3. Sorry about that. But so this one is 7.3 e to the 0.15 times 17 is about 9.4 million. Which we're expecting something larger than the starting value because we have a positive k. So 9.4 million sounds good for that one. Now, correcting question 3. Sorry about this. So we want Wessex. So I'm going to do 12.7 times e to the negative 0.15 times t, which this is what I changed. T should be 12. So this, for number 3, the correct answer, the computation that I wrote up on the board was correct. I didn't input it into my calculator. I was using an old value before I changed some numbers in this problem. So it should be 10.6 million for question 3. Sorry about that. All right, let's see if we can finish this one up without other hiccups. So questions 5 and 6. Which population is growing the fastest? Which one is declining the fastest? I'm going to get rid of this stuff up here, first of all. Let's have this a little less cluttered. Okay, so populations that are growing have positive values for k. K should be positive. So the countries that have positive values of k are Umbria and Anglia. So of those two, which one is growing faster? You just look for the higher value of k, which is going to be in Anglia. So we're comparing the 0.025 to the 0.015. So this Anglia has the highest growth rate. Which population is declining the fastest? So the populations that are declining have the negative values of k, so that's York and Wessex. Now, as far as which one is declining faster, we look for the lower value of k, the one that's more negative. And we're comparing negative 0.015 to negative 0.035, so York has the more negative value of k. York is declining faster. So that's your answer to 6. Now, I wanted to squeeze in one more question in this video. So question 7, when will the population, I'm going to abbreviate, population of York reach 4 million? So York's population, the starting population is 5.1. We've got a negative value of k, so that population is in decline. Now, the difference in this problem, the question is when. So we're solving for t. In all those previous questions, we were given a t, we were given a year. So we used that to determine the value of t. And then we just plugged in to find the population. In this problem, that is reversed. We have the population, 4 million. We're wondering what the corresponding value of t is. So what we should do is take the equation for York. I'm going to clear some extra room for this. Plug in 4. Here, let me first write the equation for York. A equals 5.1 e to the negative 0.035 t. Plug in 4 for A, for the population, and solve for t. All right. So first thing in solving an exponential equation like this is get the exponential expression, this part here, by itself. So first focus on isolating the exponential expression. And so I'll do that by dividing both sides here by 5.1. That'll cancel this coefficient, and now we've got the exponential expression by itself. Now the next task is going to be to get rid of the exponential expression. And so in order to do that, we apply the inverse operation. Inverse of an exponential expression is a logarithmic expression with the same base. So the log with base e is natural log. So the next step is to take natural log of both sides of this equation. Now, there's a really useful property. You actually learned it a couple of sections ago. So the inverse property of exponential and logarithmic expressions says that if you take a logarithm and put an exponential expression with the same base, so in this case log base e, exponential expression base e, if you put an exponential expression with the same base inside of it, these are inverse operations. They undo each other, and you're left with just that exponent p. And so in this case, natural log of e to the negative 0.035t, that simplifies to just negative 0.035t. So we have natural log of 4 divided by 5.1 equals, these cancel each other out, negative 0.035t. So now we want to divide by this coefficient to get t by itself. So divide by negative 0.035 on both sides. And that's going to give you your answer for t. And this time I'll make sure I'm using the values that I have currently in this problem. So natural log of 4 divided by 5.1 divided by negative 0.035. gives us 6.9 years. So it would be happening about now, I guess, because that's about 7 years, a little less, since 2013. Oh, that would have been last year, huh? Okay. Well, there's your answer. About 6.9 years for the population to decline down to 4 million. And I have a separate video, because this one's already way too long, for the very last, for question 8, related to these models.